Hi, guys. Okay, so let's do the homework questions from chapter 8. And in this video, we're going to cover two questions. One is from Boyles Law, the other is Charles Law. So the first one is 8.15. And in this question, we are given the volume of the balloon, which is 10 liters. Okay, and we are given the pressure at the 10-liter volume, which is 655 millimeters of mercury. Next is they are asking you to find the pressure in millimeters of mercury when the given volume is 1250, that is 1,250 milliliters. So I'm doing part D here. Actually, I had already done this, and so I'm just going to walk you through again. Okay, so 1250, that is the volume that is given. Now, the main thing here is you need to see that the units should be the same. So if you have 655 millimeters of mercury on one side, and the answer is being asked in millimeters of mercury, so we're good. But look at the volume. This is in liters and the other one is in milliliters. So we need to equalize it. And in order to do that, we know that the milliliters is equal to liters. So 1,000 milliliters is equal to 1 liter. So what are you going to do here? You're going to take 1250 milliliters and you're going to convert that to liters, not the other way around, because the preferred volume is always in liters. Okay, so 1250 milliliters times the conversion factor, which is 1 liter over 1,000 milliliters. Okay, so when you do this, you get 1.25 liters. That's the next volume. Okay, next is you're going to set up, always write the formula, write down the formula. So the formula here is the P1V1 is equal to P2V2. P1V1 is equal to P2V2. Now here we need to find P2. P2 is like the unknown, and now we're going to bring all the known variables on one side. So P1 is known, V1 is known, and V2 is known. So in order to get the V2 on one side of the equation, because V2 is multiplying by P2, so we divide it on both the sides. So that's how it cancels out from one side, and you have the V2 on the other side. So then the whole equation is written now. P1 V1 over V2 is equal to P2. Okay, next just plug in the numbers. So you have 655 millimeters of mercury times 10.0 liters over 1.25 liters. That is the volume of V2, right? We converted that into liters. So we get 5240 millimeters of mercury. Now here, remember that, just to double check your answer, pressure and volume are inversely related. Pressure and volume are inversely related. In other words, when pressure goes up, the volume goes up, the volume goes down. And when the pressure goes down, the volume goes up. So it's an inverse relationship. Now here you see that it is 10 liters. At 10 liters, you had 655 millimeters of mercury. Right. So technically this is 1.25 liters. So when the volume has gone down, the pressure should go up. So you see that when the volume has gone down, which is 1.25, the pressure has become 5240 millimeters of mercury. Okay, so that is your answer. Always write the formula. Okay, and units. And always show the steps, show all steps as I have shown you. Show all step in solving these problems. So that finishes 8.15. Now let's look at 8.25. Okay, so give me a minute. Hold on. Okay, so now we have here a situation with problem 8.25 part D, where neon gas is given. Okay, so here you're given the volume. Initial volume is 2.50 liters, and the next volume is 1,250 milliliters. Okay, so I've taken this question once again because we need to understand that the units need to be equalized, so there's going to be a conversion. Next, we are given the temperature in the first scenario, which is 15 degrees Celsius, and we need to find the temperature in the in the next scenario. So the temperature is unknown. Now here's the thing, the temperature given is in Celsius, so it's by default although they are asking you to give it in degrees Celsius, but by default, you should convert it into Kelvin. Just get used to doing it. So 273, and here you are going to get 15 plus 273 is equal to 15 plus 273 is equal to 288. So this is 288 Kelvin. Okay, so your answer is also going to be in Kelvin, but you're going to convert it into Celsius. So we know that pressure and the number of moles are constant. So write down the formula. V1 over, this is a Charles law, V1 over T1 is equal to V2 over T2. Now we need to find T2. So what are we going to do? Let's do these conversions here. V1 over T1 times T2 is equal to V2 over T2 times T2. So when you do the times T2 on both the sides, what happens is that this T2 gets cancelled and you are just left on one side. But why we had to do this? Because this T2 is in denominator. So in order to convert it into the numerator, we have to do this. And this one is the numerator. Okay. Now here, next step would be that we'll bring T2 on one side and V2 here times T1 over V1. Okay. And here we had V1 over T1 times T1 over V1 times T2. So what happens this way? This way, V1 and T1 cancel out from one side, and you have the we have it on the other side. So now your new formula becomes that V2 times T1 over V1 is equal to T2. Okay, now plug in the numbers. So another thing that we need to do is we are given 1250 milliliters. So 1250 milliliters, convert that into liters. So 1250 milliliters times 1 liter over 1000 milliliter, and that gives you 1.25 liters. Okay, so this is the volume 2, the second volume. Okay, now let's just put in the numbers. So V2 is 1.25 liters times T1 is 288K over V1. V1 is 2.50 liters. So this is going to give you the answer in Kelvin, but the question is asking you convert it into Celsius. The answer T2 should be in Celsius. So anyways, let's do this. 1.25 times 288 divide by 2.50. Divide that by 2.50 and you get the answer 144, and that is in Kelvin. But remember, now in general, if you see, just wanted to see it. So remember, there is a direct relationship between the volume and the temperature. So when the temperature goes up, the volume goes up, and similarly, so volume and temperature are directly related. So so this is technically 1.25 liters. Okay, so here we see that the volume has gone down, so the temperature should also go down. So the answer of 144 is correct. Okay, so this is coming out to be 144K, but we need to convert that into Kelvin. So 144K, convert that to degrees Celsius. So what are you going to do? You're going to take 273 minus 144, and you have 1. So this comes out to be 129 degrees Celsius. Okay, so temperature was low. The volume is low. When so this is equal to 1 second. Did I do this right? Give me 1 minute. Okay, so here's the thing that when you have the answer in Kelvin and you need to convert it into Celsius, so you minus 273, okay? Not, obviously you add, but here you subtract 273. So you have the answer in degree Celsius, and this degree Celsius is going to convert it into, you have this answer in Kelvin. And this Kelvin gets converted into Celsius when you subtract, okay? So with that said, your answer comes out to be negative 129. And this negative 129 is a smaller number. So here, this comes out to be negative 129 degrees Celsius. So now you see, you have lower temperature. The volume is 1.25. And when the temperature increases to 15 degrees Celsius, a slightly higher, the volume also increases. Okay. So this is how you just double check your answers. All right. So this finishes these two questions, 15 and 25. And in our next videos, we are going to look at the next questions. Okay. Thank you.